So let's look at problem number 11 here. What was given to you is the derivative of a function, and we know my original function is continuous, and I know one point. So I have my derivative of the function, which is this piecewise function I have here. So what I'm looking for is, and we want to find out what's f of x, f of 0, f of 7, and they want you to find out the integration of f prime of x, 7, integrate 0 through 7. So according to the fundamental theorem of calculus part 2, which we've learned, since the original function is a continuous function, so it's technically supposed to be this. So if we were able to find both of the values, we should be able to find the answer for the last piece. Then the question is, what's f of 0? Well, what I know for now is my function at this piece, f of 4 is 0. And I'm looking for what's going on at this point. So I want to move backwards. Well, according to the fundamental theorem of calculus, what I know is that the integration from point A up to 4, f prime of x dx is supposed to be f of 4 minus f of 8. And because if I were to look at my derivative function, I realize my derivative function is a piecewise function. And if I were to look for f of 0, so I meant to say 0 up to 4, f prime of x dx is f of 4 minus f of 0. Well, I can't really do the integration in one shot because my derivative is a piecewise function. So what I have to do is I integrate from 0 to 1, and I integrate from 1 to 2, and I integrate from 2 to 3, and I integrate from 3 to 4. So I split this integration into 4 pieces because my function was cut into 4 pieces. In the first piece, my derivative function, which is given as a height of 3, so this is what I have. And in the second piece, function value of the derivative, the value of the derivative is -1. This is positive 1. And here, between 3 and 4, it's -2. So integrate from 3 to 4, I'm having -2. So I can finish the integration of those pretty easily because that's essentially the net area. It's a constant function. So you can use a rectangular shape to do the calculation extremely efficiently, but of course you can carry out the calculation by finding the antiderivative, use the fundamental theorem of calculus to find it. So anyway, bottom line, it's 3 minus 1 plus 1 minus 2, which is supposed to be 1. So what I find out is that the integration of 0 through 4 for f prime of x is supposed to be 1. I also know that that's supposed to be f of 4 minus f of 0. So what I'm trying to claim here is 1 is f of 4 minus f of 0. I do know f of 4 is 0, so 1 is 0 minus f of 0. So f of 0 must be -1. So I find my answer for the first part. Along the same line of thinking, I could try to construct this similar integration, but I stop at 7. So I would have 4 through 7, f prime of x dx to be f of 7 minus f of 4. I do know what's f of 4. I do know what this piecewise function is like between 4 and 7. So I can build my integration 4 through 7, 4 through 5, in which my derivative function has a value of 3, and then I have 5 through 6, it has a value of -3, and I have 6 through 7, which has a value of 2. So that is my integration for the left side. I can find it as 3 minus 3 plus 2. My right side was supposed to be f of 7 minus f of 4. According to the problem, f of 4 is 0. So 2 is f of 7 minus 0. So f of 7 is 2. Therefore, my last piece is -1 minus 2, which is -3. So basically, we use fundamental theorem of calculus with the help of one point, as well as the function value at the derivative value at as a piecewise function, I can use the integration to help me to identify f of 0, f of 7. Hence, I know what's the integration of 0 through 7 for f prime of x.